part B in this question, we need to work out what angle the basketball will enter the hoop. This can be done by finding the total final velocity and then working from there using trigonometry. So firstly, we have the components. We have the x component and the y component of the velocity. But we know the initial, but we want to work out the final now. So we can use the equation v final is equal to v initial plus acceleration times time. So in the x direction, the Vx of f, so the final x velocity, will be equal to the initial x velocity, which we worked out last episode to be 12 cosine of 35, plus acceleration times time. In this instance, as we are using the x axis, there is no acceleration as we are not working with air resistance. So this whole term would cancel to 0. So this is just going to be the final velocity as well. Now for the y final velocity, we'll take the initial y velocity, which we worked out to be 12 sine of 35. And then we need acceleration, as we're working in the y-axis. The acceleration, we will take it as negative g downwards. So it will be plus negative 9.8 times time. We did work out time last episode. It's somewhere here. It was 1.30286 and on and on and on. But we rounded it to 1.30286. I think that's what we rounded to. So we will just input that after. So to add these together, imagine we want to find this little part here. But this also forms a right angle triangle. So this right angle triangle, we've worked out the horizontal line here to be Vx. So let's just name that 12 cosine of 35. Then this side here, or the opposite, because we're taking this angle, will be the Vy. So I'll just name that as Vy. So to work out this angle, we can use Pythagoras' theorem, which states a squared plus b squared equals c squared. So we could input these values into the Pythagoras theorem and solve using a calculator. Then we square root it. And once we do all that, I already pre-inputted into my calculator, you get 11.4568 on and on and on. So now that we have this value here, we have our total final velocity. So our final velocity in total will be 11.45687474993. So what we want to do now is, in reference to the individual components, work out an angle. So the final x velocity would be equal to the final velocity times the cosine of theta, because we will be dealing with the angle as theta, and then we can solve using inverse trigonometric functions, but that's later. So we have this. Now, this will be set equal to what we already established here as the x final velocity, so 12 cosine of 35. So from this, we could work that out as a number, and that will give us something. I don't know the exact number off the top of my head, but then we can divide it by our final velocity here, and then that will give us the cosine function. So let's do it into the calculator. 12 cosine of 35. We're going to divide that by, let me just get this number. We're going to divide it by that number right there. Then we're going to take the inverse cosine, so we can work out what it's equal to. Wait, let me just grab my other calculator real quick. So on my other calculator, this one's just easier because it already has the inverse cosine function right there. So I'll just type it in, and then we'll get back. So I've typed it into the calculator, and I've done it as the negative cosine function, and we get this number right here. 30.908934. And on 86 if you want to include that. So to round that, as the question says that it wants us to round it to the nearest whole number, so it will be 31. So theta will equal to 31. Meaning that when the ball enters the hoop, it will be 31 degrees below the horizontal, meaning like this. It will be 31 degrees below the horizontal as it enters the hoop. So it will be right here.